All right, we're going to look at diagonals of quadrilaterals in our next lesson, which is now. So let's just have a look at what a diagonal is. Now, a diagonal of a quadrilateral is an interval, right, that joins opposite vertices. Now, when we're talking about an interval, if I draw a line there, an interval is a line between 2 points, right? It's got a particular length. So a diagonal joins opposite vertices. So if I take, for example, vertex A and vertex C, the line joining those two vertices is called a diagonal. So if I just draw a line between those two, so that there, that black line I just drew, is called a diagonal. And also, if we look at vertex D and vertex B, uh, I can join those two vertices together, and that is also a diagonal. So let's just do that. So it's going to join D and B. Okay, so any line which joins opposite corners or opposite vertices of a quadrilateral is called a diagonal. So what we're going to do is look at the properties of the diagonals in a quadrilateral. So for example, if you look at the black diagonal and you look at the red diagonal, we're going to see if they're the same length, or we're going to see if they meet at a particular angle. Okay, so, and we're also going to see if one diagonal or both diagonals meet in the middle. Okay, so let's have a look. So in that diagram we just drew AC, so AC is one diagonal, and BD is the other diagonal. Now, some terminology you need to know. Bisect means to cut in half. So let's have a look at the first diagram here. Now, you've got an angle here. A, B, C is the angle, and that's marked with the arc. And this line here, BD, this interval BD, that bisects the angle. That means it cuts the angle in half. So in other words, this angle here, right, is cut into two halves, which are the same. So this angle and this angle there are equal. Okay, so the two halves are equal in this particular angle, and the line which cuts them in half is BD. So let's just show that. So BD is this line here. So the red line, okay, cuts the pink angle into two halves. And that means we say that the red line bisects the angle through which it passes. Okay, so the red line passes through the pink angle, angle ABC, and the red line cuts the pink angle into two equal halves, marked with the X. Okay, so that's what we're going to look at today to see whether a diagonal actually cuts uh, an angle in half, right? The other thing we're going to look at is the bisecting of an interval. So, for example, this line here, CD, so let me just draw that, trace over that. That line there, CD, cuts AB, and AB is the interval, cuts AB in half, and that is indicated by these dashes there. Okay, so if I was to highlight that, let's just do that now. Okay, so this line here, the black line, is cut in half by the red line. Okay, and the way that we show that is with these dashes. So the blue dashes there, right? The blue dashes there. We're saying that this half here is equal to this half here. So we say that CD cuts AB in half. And the word we use for that is bisect. So CD bisects AB. All right. Now what you're going to do is you're going to click on this little link here, and that link is going to take you to this web page. Okay, and that web page, let me just hide this for a minute. That web page will allow you to look at the properties of the diagonals of all the different quadrilaterals. Okay, so let's do that now. You've clicked on the link and you've opened that up, and what we're going to do now is answer these questions, right, using that link. So the first question for the parallelogram is, are the diagonals equal in length? So let's have a look. So let's look at the orange diagonal first. Right, now if you look at the orange diagonal, and I'm just going to remove the angles for a minute. So this little checkbox can hide the angles. So let's just look at the lengths of the diagonals. So you can see the orange diagonal is 5.2 from D to E and 5.2 from E to A. So altogether, that orange diagonal is 10.4. Now, if you look at the black diagonal, from C to E, it's 5.1, and from E to B, it's 5.1. So that's a total length of 10.2. Now, 10.2 is not the same as 10.4. So we're just going to go back to our notes, and we're going to say, are the diagonals equal in length? And the answer is no. Okay. Now, do the diagonals bisect each other? That means, do they cut each other in half? So let's just have a look at that. You can see here that the black line has got 5.1 from C to E as a length, and from B to E, it's also 5.1. So that orange line, the orange diagonal, cuts the black diagonal in half. Now, you can also see on the orange diagonal that it's 5.2 units from A to E, and from D to E, it's also 5.2 units. So in actual fact, the black line cuts the orange diagonal in half as well. So both those diagonals cut each other in half. Okay, so, and that's actually true. If we move and make another parallelogram, you can see that that's always true. Okay, so you can see here that the orange diagonal has 7.6 on either side of point E, and the black diagonal has 5.9 on either side of E. So that means the orange diagonal cuts the black diagonal in half, and the black diagonal cuts the orange diagonal in half. So coming back to our second question, do the diagonals bisect each other? And the answer is yes, they do. They do bisect each other. Okay, so the way we're going to show that is this half is equal to this half. Okay, and now this half is equal to this half. Okay, so that's the dashes I want you to put in your diagram. Now, do the diagonals meet at 90 degrees at right angles? Well, let's have a look. No, they don't. 58.2. Sometimes you can make it so that they sometimes do. So I could turn this into a rectangle, sorry, a square if you wanted, and you might get 90, but not necessarily. So the answer is no to that question. The diagonals do not meet at 90 degrees. So I'll put a no there, right? And you might just want to put some sort of an angle arc there, possibly, but the answer is no. Now, do the diagonals bisect the angles through which they pass? Okay, now, to understand this question, we need to know what angles do the diagonals pass through. Well, this angle here, right, the diagonal passes through that angle there, and the diagonal also passes through this angle here. Okay, so if I draw a different colored line there, let's have a look. So now, there's the red diagonal. Now, does the red diagonal cut the blue angles in half? Let's have a look. Right, so here's the diagonal there. If I show the angles on the diagram, you can see that these angles are not equal. Right, so the black diagonal does not cut the angle in half because you've got 49 degrees and 24.3. They're not the same value. And similarly over here, these angles are also different. So no, it doesn't cut the angles in half in the corners. All right, so the answer to that one is no. All right, so we're going to put a no there. So we only got, right, one yes. Right, the diagonals bisect each other for a parallelogram. Okay, So let's go to the next one. Now for the rhombus, are the diagonals equal in length? Let's go back to our web page. Now, to get the rhombus, we need to slide this up one. See the slider? That'll take you to a new shape. And let's just hide the angle so we've got less information to look at. Now, are the diagonals equal in length? Well, not really. You've got 4.9 and 4.9, that altogether that is 9.8. And you've got 3.5 and 3.5 altogether, that is 7. So the orange diagonal is 7 units, the black diagonal is 9.8. They're not the same length, right? And you can see that you can change this into another rhombus, and that property shows you that the diagonals aren't equal in length. So we'll go back to our notes, and here we go. Are the diagonals equal in length? And the answer is no. All right. Do the diagonals bisect each other? Well, let's have a look at this. Do the diagonals bisect each other? Well, it looks like they do, because you've got the 4.8 and the 4.8. So that means from F to J at the center is 4.8, and from J to H is 4.8. So the black diagonal cuts the orange diagonal in half. And have a look at the black diagonal. You've got 3.6 and 3.6. So from G to J, it's 3.6 units, and from I to J, it's 3.6 units. So yes, the orange diagonal bisects the black diagonal, and the black diagonal bisects the orange diagonal. So let's put a yes for that. Okay, do the diagonals meet at right angles? Let's have a look. Well, let's click the box here to show the angles. Have a look. Yes, they do. You can see that no matter what I do to my rhombus, I can change it to a different rhombus. The diagonals always meet at 90 for a rhombus. Okay, so the answer for that one is yes. All right, so we could mark that on the diagram here and say that, yep, there's a right angle. They always meet at 90. Now, do the diagonals bisect the angles through which they pass? So let's have a look what that means again. So let's take this diagonal. So if I take this diagonal, does it cut the angles through which they pass? So the diagonal passes through this angle, and the other diagonal passes through this angle. Okay. Now, does that red diagonal cut the blue angles in half? Let's have a look. Here we go. Now, have a look at this. We've got 55.6 here, and this angle is also 55.6. This angle here is 55.6, and this angle is 55.6. Now look at the other diagonal. The orange diagonal also cuts the angle in the corner in half. So we'll have a look. We've got 34.4 and 34.4, 34.4 and 34.4. So no matter what I do, you can see that the diagonals always cut the angles in the corner in half. You can see those two values are the same, and these two values are the same. So the answer for that one is yes. Now we're going to mark this on the diagram. So what we're going to say is that this angle here is equal to this angle here. And also, if you look at the picture, these are the same value. Okay. Now let's look at the other one, of course, which is, hang on, what's that? I've got the laser pointer. So let's look at the other angles. Now, for the other angles, we have, we'll use different symbol. So this diagonal here, the black diagonal, cuts this angle in half. So we're going to say that those two angles there are equal. And then here and here. So make sure you've got the same markings as me. All right. So the black diagonal cuts the pink angle in half. Okay, so I'm going to put a double arc there and a double arc here. Okay. Now the other thing so we've marked that the last one, we've done that one. Now we've done the diagonals meet at 90, and the diagonals bisect each other. So let's put that on there as well. So for the diagonals bisecting each other, we have not marked that on the diagram. So let's do that now. So that means the red line is cut in half. Yep. And the black line is also, you need to have the same dashes as me. There we go. Let's move on to the rectangle. Now, for the rectangle, are the diagonals equal in length? They kind of look like they are equal in length, but let's have a look. Go back to our shape and up to the rectangle. Let's untick the box there so we just look at the length of the diagonals here. So look, 4.5 and 4.5 is 9, and 4.5 and 4.5 is 9. So the black diagonal and the orange diagonal are the same length. Now you can change your rectangle any which way you want, and the diagonals will always be the same length. Okay, you can see here that both the diagonals are 8.6. Yep. And no matter what you do, the diagonals will always be equal in length. Okay, and not only that, you can see they bisect each other as well, can't you? You can see that you've got 3.7 and 3.7 and 3.7 and 3.7. So the orange diagonal cuts the black diagonal in half and vice versa. So let's put that on our sheet. So we have, are the diagonals equal in length? The answer is yes. Do the diagonals bisect each other? Yes. Okay. So let's mark that on the diagram. So the diagonals are the same length and they cut each other in half, which means I've got a single dash here and a single dash here to say that those two halves of that diagonal equal, and a single dash here and a single dash here. Now I'm not going to put double dashes because the diagonals are actually the same length, which means each half of each diagonal is the same length. So we'll leave that there as is. Now, do the diagonals meet at 90 degrees? Let's have a look. I'll put my angles back on. Oh, no, they don't. So no matter what I do, you might be able to get it to equal 90, but it's not always going to be 90. So the answer is no, they don't. So you can see 132.5 is not 90. You can also see that the diagonals don't cut the angles in half. You can see 66.2 is different to 23.8 and so on, okay? So the last two questions, do the diagonals meet at right angles? The answer is no, they don't. And do they bisect the angles through which they pass? And the answer is no. Okay, so for rectangles, that they have equal length for the diagonals, and also the diagonals cut each other in half. They bisect each other. Let's look at the square now. Now for the square, let's go back to, here we go. So let's untick the box for the angles. Now look at the diagonals for the square. They are actually the same length, aren't they? 2.8 and 2.8 is 5.6 altogether. And the orange diagonal, we've got 2.8 and 2.8, so that's 5.6 as well. So the diagonals are actually equal in length. No matter what I do, you can see the diagonals are always equal in length. And not only that, you can see that just like the rectangle, the diagonals bisect each other. Okay? So let's have a look at that. So come back to our diagram. Are the diagonals equal in length? The answer is yes. So let's put down a yes for that. Do the diagonals bisect each other? Yes, they do. So let's mark that on here. So we've got single dash here, single dash here, single dash here, single dash here. Now, let's go to the angles part. Do the diagonals meet at right angles? Let's come back to our diagram. Click on the angles box. Yes, you can see that no matter what I do with my square, the diagonals always meet at that right angle. And have a look at the angles through which they pass. Yes, they actually bisect those angles, and those angles are 45 all the way through. Okay, so we can update this on our picture then. So do the diagonals meet at right angles? The answer is yes. And do the diagonals bisect the angles through which they pass? The answer is yes. So let's put those markings on the picture. So we've got a 90-degree angle at the center, and all of these angles here are 45 degrees. So the diagonals cut those in half. Okay. 45 degrees, 45 degrees, 45 degrees, 45 degrees. Okay, let's go to the kite now. All right, now, are the diagonals equal in length? Well, have a look. You can clearly see from the diagram the answer is no. You could make a kite where they're equal in length, but they're not always going to be equal in length. So what we're going to say then is the answer for the first one is no. Okay. Now, do the diagonals bisect each other? Well, let's have a look. If I go to the picture, so let's go up to number 5 here and untick the angles. Now, you can see that 2.3 and 4.6 are different. Okay, so no matter what I do there, those two lengths are not going to be the same necessarily. I could make them the same, actually. I could force them to be the same, but they won't always be the same. But have a look at the orange diagonal. No matter what I do to the orange diagonal, the black one always cuts it in half. Right? You can see here I've got 4.4 and 4.4. So no matter what I do, that orange diagonal is always cut in half by the black diagonal. Okay, so let's go back to the questions. Do the diagonals bisect each other? And I'd say, well, to qualify that, I'd say only one diagonal is bisected. So I'd write down only one diagonal is, I'm going to run out of room here, so I write up, only one diagonal is bisected. And it's just this one here. Okay, so I just got a single dash there and single dash there. Now, next question, do the diagonals meet at right angles? Let's have a look. If I click on the angles box, you can see here that I've got the 90 degrees. So yes, the answer is they do. I'm going to put a little right angle there to say they do. Let's just, yep. Now, do the angles bisect the angles through which they pass? Well, that's the other question we've got to answer. Have a look. Now, the orange diagonal, you can see it does not cut the angles in half. You've got 32.3 and 58.6. But the black diagonal cuts the angle, the top and the bottom angles in half. You can see there, 57.7, 57.7, 31.4, 31.4. And no matter what I do, those angles are always cut in half. Okay, no matter what I do there. So let's come back to notes, and we're going to write down this one is yes. And do the diagonals bisect the angles through which they pass? And the answer is only one diagonal bisects the angles through which they pass. Okay, only one. So the way we're going to mark that is this angle here is equal to this angle here, and this angle here is equal to this angle here. Okay. Now let's move on to the trapezium. Now for the trapezium, you can see the diagonals aren't equal length. They don't bisect each other. The answer for this is no. You can go, we can verify that in a minute, but I'll put down no for that, no for that, no for that, and no for that. That's all no's. And you can see if I go back to the web page and I'll go up to the trapezium, you can see that it's no for everything. Okay, so that's something to be aware of. All right, now we've got those properties. You're going to have to find the values of the pronumerals. So let's have a look at the first one. You've got to find the length of x. Now, x is this length here in red. Okay, that's there. So This is a parallelogram. You can tell because the opposite sides are equal. So it's a parallelogram. So you've got to look at your properties of the parallelogram and tell me what you think. What is x equal to? So let's have a look. So we're going to write down x is equal to, it's equal to 6 centimeters, right? Because it's, this half here is the same length, because we know that the diagonals of a parallelogram bisect each other. So now I haven't left you enough room here for the reason, so we're going to have to squeeze this in. So the reason is actually, I'll tell you what we're going to do to make it easier. Okay, just to make it easier for space, let's do the other one now, and then we'll put the reason at the end, because it's the same reason for both. Now, how long is this part here? This is y. So that's going to be the same length as this part here, okay, which is 8 centimeters. So the reason for both of them, so I won't put a reason here, I'll just put down the diagonals of a parallelogram bisect each other. Okay. All right, let's move on to the next one. Now we've got to identify what shape this is. You can see that all the sides are equal, right? You've got the single dash here, 1, 2, 3, 4. Okay, so it's a rhombus because all the sides are equal. So let's have a look at what x is equal to. So look at the properties. What angle do the diagonals of a rhombus meet at? If you look back at your notes, they meet at 90 degrees. So x is 90. Now I've run out of room here, so I'm just going to cross out this little bit here. I'm going to write down the reason as the diagonals diagonals of a rhombus meet at right angles. Now, another word for meeting at right angles is perpendicular. So you could say that x equals 90 because the diagonals of a rhombus are perpendicular. We'll write that down in a minute. Let's do theta now. Okay, theta is this angle down here. So now we know that for the properties of a rhombus, that the diagonals bisect the angles through which they pass. So this angle here must be equal to this angle here. So theta is equal to 32 degrees. And the reason being the diagonals of a rhombus. Diagonals of a rhombus right? Diagonals of a rhombus bisect the angles. Bisect the angles through which they pass. Okay. All right. So now what I'm going to get you to do for the rest of the questions is to complete the questions with the reasons and also the values for the pro numerals.